Hello guys, welcome to the channel. In this particular video, I will explain the problem frequency game. This problem is asked in a Google interview, so let's see the problem statement. Here is the problem. It says that you are given an array A of size n. The elements of the array consist of positive integers only, and your task is to find the largest element with minimum frequency. So pretty simple and straightforward. One example is given here. Let me explain. So it says that we are given an array like this, and in this array our task is to look for an element which has the minimum frequency and the element should be the largest. So first of all, let me store the frequency of all the elements here. So 2 has the frequency of 2. We have 2 occurrence of 2, right? And we have 5 with frequency of 1. Then we have 50 with frequency of 1 again, and then we have 1 and the frequency is again 1, right? This is how the frequency chart look like. Now our task is to look for the minimum frequency. So the minimum frequency here is 1, you can see here, and there are 3 elements with the minimum frequency. The first is 5, then 50, then 1, right? Among these elements we have to return the largest element, and the largest element is going to be 50. This way we will be able to get the largest element with minimum frequency, which is 1, right? So the answer is going to be 50 here. I hope you have understood the problem statement. Very simple and straightforward. Now let's talk about the solution. Here I have written one example, and we can solve this problem in just 2 steps. The first is storing the frequency of all the elements. So how we can do this? We can simply use a map. So in C++ we can use an unordered map, and in Java we can use a hash map. Like if I store the frequency of each element with the first step, then I will get the frequency of 2 as 2, the frequency of then 4 as 2 again, frequency of 5 as 1, frequency of 1 again 1, and the frequency of 50 again 1, right? This is how the frequency map looks like. And after this we are just going to search for the largest element with the minimum frequency. But what is the minimum frequency here? This is the question. So again we can break the step 2 into 2 steps. So step 2 is going to have 2 steps. First is finding minimum frequency, and after this looking for the largest element. So looking for largest element. How we are going to store the values in the map, this is something which I will show you in the code, because this varies with the code language. So here I have written the code in C++ and Java and Python. So I'm going to show you the implementation in all, but the main thing that I'm going to show you is finding the minimum frequency and then looking for the largest element. The task is quite simple. First of all, I'm going to have a frequency which will have value initially minimum value, right? And after this I'm okay, I think it should have the max value, and so that we can minimize the frequency. And after this I'm simply going to traverse over the map values. So I'll write for every key in map key set in map. Once I have the key, I can get the value. So if my map dot get key, this will help me to get the value associated with that key. For example, the value associated with this 4 is 2, right? So this way I can get the frequency, and if this frequency is smaller than my initial frequency, in that case I can update the frequency. So my frequency will become now map dot get frequency, right? This is how I can get the minimum frequency. Once I got the minimum frequency, then I can simply look for the largest value. So in order to do this, I'll simply traverse the map again. For key in map, I'll do one thing, that if the frequency of the current key, if map dot uh, get key again is equal to the minimum frequency that we have, right? Minimum frequency. In that case, we can simply do one thing. We can have our answer equal to max of answer and key. This is how we can get the maximum value, right? And answer is initially going to have minimum value. These are the 2 steps that we need to follow in order to solve the problem. Okay, but One thing that I want you to notice here is we are doing two iteration over the map, right? And we can do the same thing in just one iteration. Let's see how we can do this. The task is quite simple. First of all, I'm going to initialize my frequency with max value, and after this my answer is going to have minimum value. Now we are going to traverse the map just once. So for every key in map, right? For every key in map, if my frequency, if map dot get key is something which is smaller than frequency, then my frequencies and answer are going to be updated. So I'll write my frequency equal to, okay, my frequency is now going to be map dot get key, right? And my answer is also going to be updated because this is the minimum frequency, new minimum frequency, right? So answer will become the current key. And if like else if the minimum frequency or the current frequency is equal to the minimum frequency, so if my map dot get key, this is the current frequency, is equal to the current minimum frequency, inside this condition I am going to have answer equals to max of answer comma key. Now you can see that we are doing the same task in just one iteration. So this is how we can solve the problem. Once we have stored all the values, so the first step is always going to store all the values. After this, we can simply do this iteration in order to get the maximum value with minimum frequency, right? So now I hope you have understood the problem and solution. So talking about the time complexity, so the time complexity is going to be very simple. First of all, I'm doing an iteration which is O of n to store all the values in the map, right? After this, I'm again going to do one iteration which is O of n again in order to get the minimum frequency and maximum element, right? So this is how the total complexity is going to be. Time complexity is going to be O of n, and space complexity is again O of n. Why? Because I am storing all the values in the map, right? In this step. So now let me show you the code. This is the code. On the left hand side I have the Java code, and on the right hand side I have the C++ and the Python code, right? So you can see that this is the Java code. First step is this one. Here I am storing all the values in the map, and after this I am doing the same thing that I have explained you. Now you can see that C++ code is also similar. Just the way to implement is a bit different. You can see that here we use unordered map in order to store the values, and in Python this is how we store the value in the map, and after this we are again going to do the same step. So this is all about this problem. The problem is quite easy. I hope you guys will like the explanation. Thank you.